Okay, we're going to wrap up our notes on, or I guess during the break, and today's notes are going to be over something called inscribed angles. Oops. So let me just run through some of these definitions with you first and foremost. So we got a picture of a circle. On this circle are points A, B, and C, and P is in the very center of the circle. So the first definition is an arc, and an arc is a portion of the circumference of the circle. So the circumference of the circle is just is the length of the circle all the way around. So the circumference, if you measured the circumference of a circle, you would start here, go all the way around, and then go back. So you can think of sort of circumference is kind of like the perimeter of a circle. Okay, and an arc is a portion of the circumference of a circle. So the circumference of this entire circle, you start at A, you go all the way around, you end up back at A. One example of an arc would be just a portion of the circumference. So from A to B would be an example of an arc. So you can write, there's a little arc symbol like that, and AB. Okay. There are what are known as minor and major arcs. Excuse me. So right here we have the center P, and we have this central angle going from P to A and then from P to B. So we see this angle that forms here. We see this little slice of pie that forms from that. So the minor arc is going to be the portion of the arc that's inside on the interior of that angle from A to B, and then your major arc is going to be the larger portion. It's going to be all this space out here. So the minor arc is the set of all points inside of angle APB. So this is my minor arc, and it's minor because it's smaller. So my minor arc can be called AB. Okay, so my minor arc for this circle is AB. My major arc is the set of all points on the outside of angle APB. So here's my major arc, is this space out here, and we can kind of, that's written out right there on this circle for us. So the minor arc is AB, the major arc is going to be A, and then I got to touch C and then get all the way back around to B. So my major arc is going to be ACB. Okay, so that's it for arcs. Now let's talk about angles just for a quick second. So we have a central angle and we have an inscribed angle. An inscribed angle is an angle whose vertex is on a circle and each side of the angle intersects the circle at another point. All that basically means is we got point A, point B, and the vertex of this angle has got to be on the circle itself. So if we have an angle going from C to A and then from C to B, that's an inscribed angle because the vertex is on the circle. If it's an inscribed angle, the vertex is on the circle. So the inscribed angle of this picture is going to be angle ACB. So now let's look at the central angle. We talked about central angle a little bit a couple classes ago or a couple days ago. Let me slide this down just a little bit. So the central angle of a circle is an angle whose vertex is in the center of the circle. So the inscribed angle, the vertex is on the circle. If it's the central angle, the vertex is in the center. So my central angle is going to be angle, and again, where the vertex is in the center of the circle. So angle APB. So angle APB. So there's some definitions for you. I'll ask you to write those down just so we it's easier to memorize something once you've written it down. And then lastly, let me find, there's a theorem called the inscribed angle theorem. And all that says is this. It says the measure of a central angle is twice the measure of any inscribed angle that intercepts the same arc as the central angle, that intercepts the same arc as the central angle. So the inscribed angle theorem states that the measure of a central angle is twice the measure of any inscribed angle that intercepts the same arc. So for example, if we're looking at this picture right here, if our central angle angle APB, if angle APB is 50 degrees, well, my central angle is twice the measure of any inscribed angle that intercepts the same arc. So this arc here is AB. The central angle goes from P to A and then from P to B. If this was 50, then according to this theorem, my inscribed angle that intersects A and B, but my vertex is over here, this is going to be half of 50, so 25. So if this angle is 50, this angle is going to be 25. And that's only true if my inscribed angle intersects these points, the same points that my central angle does. We'll do some examples looking at this.